Hi, I'm Lauren. In this video, I'll explain projectile motion using dance, which isn't an activity people associate with physics, but in fact, physics is what makes dance possible. Projectile motion starts with vectors. Vectors make up many variables such as force, velocity, and acceleration. Their most important characteristic is that vectors at right angles don't affect each other. Because of this, vectors can be divided into components along the x and y axes. Newton's second law states that force is mass times acceleration. This means that when there is no force acting on an object, like when it's a projectile in the air, acceleration must be zero because all objects have mass. Newton's third law explains the normal force, which counteracts gravity. It is what allows dancers to spring into the air when they apply a force to the ground. The acceleration due to gravity is always 9.8 meters per second squared. Kinematics is defined as motion with constant or no acceleration. There's a horizontal and vertical version of the set of equations. You can use all three equations when acceleration is constant, but we'll only use the first one. Now I'll walk you through some practice problems involving different types of leaps. First, watch this video of a center leap. This is a visual representation of the path the dancer's center of mass takes through the air. Listen as I read the question. A dancer leaps from the ground at an initial velocity of 3.74 meters per second and an angle of 74 degrees. She lands 1.2 meters away from her starting position. At what time does the dancer land? The process to answer this question is actually quite simple. The first step is to solve for the x component of velocity. Then you simplify the kinematics equation. We know that the dancer started at 0 meters and that the acceleration in the x is 0 because there isn't a horizontal force acting on the dancer. The last step is to substitute known values into the simplified equation and solve. Now watch the video slowed down. In the second problem, you'll see a switch leap. A dancer leaves the ground at 2.698 meters per second and at an angle of 64 degrees. Her center of mass has an initial height of 1.11 meters, and she reaches her max height when she's 0.465 meters away from where she started. What's the maximum height of the dancer? To solve this problem, you will first find the components of the velocity. First, solve for the time the dancer is at her max height. In the next step, the gravity is negative because it's opposite the positive y direction. Lastly, sub in the known values and solve for the maximum height. Watch the video again slowed down. Thanks for watching!